Right now, there are thousands of satellites orbiting Earth. They map forests, track weather systems, and capture images of nearly every corner of the planet. Most of the time, what they see is predictable. Mountains, deserts, oceans, cities. But occasionally, they capture something unusual enough to get attention. Not because it's mysterious, but because it doesn't immediately make sense. In the early 2000s, Earth observation satellites captured images of a remote desert region in North Africa. At first glance, the area looked completely empty. Just sand, no cities, no infrastructure, no obvious signs of activity. But when researchers enhanced the imagery to study terrain patterns, they noticed something unusual. Large geometric formations spread across the ground. The shapes were large enough to be seen only from high altitude. And at that scale, they appeared unusually structured compared to the surrounding environment. In satellite science, unusual patterns aren't rare. Deserts especially can create visual effects that look artificial from above. Wind erosion, shadow alignment, and lighting angles can all produce geometric illusions. At first, scientists considered exactly that, a natural explanation, because most anomalies seen in satellite data turn out to be environmental effects. But the formation here was large enough that it drew interest for further review. Not because it suggested anything unknown, but because it was worth verifying more carefully. When additional satellite passes were analyzed from different times and angles, the same general pattern appeared in multiple datasets. However, the clarity and appearance varied depending on sun angle, sand movement, image resolution, atmospheric conditions. This variation is normal in remote sensing. Earth's surface is constantly changing. Even stable environments can look different depending on how they're observed. At this stage, researchers explored a few possible explanations. Not competing theories of mystery, but standard scientific categories. Natural geological formation. Some desert regions form repeating ridge and erosion patterns over time. These can appear structured from orbit. Optical and imaging effects. Satellite images are not direct photographs in the traditional sense. They are constructed from sensor data. And that means compression artifacts, contrast enhancement, sensor blending, can sometimes exaggerate patterns, misinterpretation of scale. Objects that are small or fragmented on the ground can appear connected when viewed from very high altitude. Each of these explanations is common in Earth observation science, and none of them require anything unusual to occur. So why did the image attract attention in the first place? Not because it was unexplained, but because of how human perception works. The brain is extremely sensitive to symmetry. Even when patterns are created by random natural processes, we tend to interpret them as intentional. This is known in cognitive science as pattern recognition bias. It's the same reason people see shapes in clouds or faces in rock formations. From space, that effect becomes even stronger because we lose ground-level context and rely entirely on visual interpretation. After multiple analyses across different datasets, no confirmed evidence was found of artificial construction, engineered structures, or unknown installations in the region. Instead, the consensus among Earth observation researchers is that the imagery reflects a combination of natural terrain variation and imaging interpretation effects. When images like this attract attention, the next step isn't speculation, it's observation. Researchers simply collect more data, more images, more angles, and more opportunities to see the same location under different conditions. Because a single image can sometimes be misleading. A shadow may appear larger than it really is. A change in lighting can emphasize certain features. And differences in image quality can make ordinary terrain look unusual. This is one of the reasons scientists rarely rely on a single observation. Instead, they look for consistency. If the same feature appears again and again, across multiple images, confidence in the interpretation increases. In environments like deserts, this process becomes especially important. The landscape may look permanent, but it's constantly changing. Wind moves sand, surface textures shift, and small variations in terrain can appear very different when viewed from high above. Over time, additional observations of the region continued to support the same conclusion. The patterns were real, but they were also consistent with natural features already known to exist in similar desert environments. And that's often how scientific investigations end. Not with a dramatic discovery, but with a clearer understanding of what was being observed. What first appears unusual can become familiar once enough information is available. And in satellite science, that extra information often makes all the difference. One of the challenges of satellite imagery is scale. From orbit, scientists can observe enormous areas of the planet at once. Entire mountain ranges, hundreds of kilometers of desert, even weather systems stretching across multiple countries. But as the scale increases, context can sometimes disappear. Features that seem connected from high altitude may be completely separate on the ground. Small changes in terrain can appear much larger than they actually are. And patterns that look unusual from space may seem perfectly ordinary when viewed up close. This isn't a limitation of satellite technology. It's simply a consequence of perspective. Every way of observing the world reveals certain details, while hiding others. From the ground, we notice individual rocks, plants, and structures. From space, we see patterns, shapes, and relationships across entire landscapes. That's why satellite imagery is most powerful when combined with other sources of information. Maps, geological surveys, historical records, and observations collected directly from the surface. Together, they provide a more complete picture of what is actually being observed. Earth observation commonly combines satellite data with ground-based information to improve interpretation and understanding of large-scale features. In the case of this desert formation, the image itself was only the starting point. The real answer came from examining additional data, comparing observations, and viewing the same landscape from multiple perspectives. Because in science, an image is rarely the conclusion. It's usually the beginning of a closer look. And sometimes, the more closely we look, the more familiar something becomes. This case isn't about a hidden discovery. And it isn't about something unexplained. It's about something more interesting from a scientific perspective. How easily large-scale data can look unfamiliar when viewed from a distance. Satellites don't interpret what they capture. They only record information. It's up to us to interpret it correctly. And sometimes, that interpretation depends heavily on perspective. From the ground, the world is detailed and familiar. From space, it can look abstract, even unfamiliar. But that doesn't mean something unknown is there. It just means we're looking at it from a different scale. So, the next time you see a satellite image that looks unusual, it's worth remembering. Not every pattern is a mystery. Sometimes, it's just Earth, seen from a different angle.